I guess to start with, I would usually ask people to give an introduction. I don't think you need an introduction. I think you're one of the most well-known people in the Ethereum ecosystem. But I think what's fascinating is over the last, let's say 6 months, 8 months, EigenLayer has gone from being the preeminent protocol in restaking to one of the preeminent protocols in both restaking and AI. And I'd love to kind of know your thinking and kind of your thought of how you decided to make that journey and decided to kind of lead EigenLayer in that direction.
Yeah, from the starting, actually, like the first white paper I wrote on EigenLayer was not on restaking.
Yeah.
So it was called Unleashing the SaaS Era of Crypto. Mm-hmm. So we had the name EigenLayer. Eigen, German for your own layer. Anybody should be able to build and deploy new and interesting services. So we had this before we even knew what is restaking, right? So which turned out to just be an accident of history. So, but the core goal was we looked at how applications get developed in crypto, right? When you think about application development in crypto, it looks very much like application development in the Web 2 world in, say, 1995, okay? So in 1995, if you want to build an application, you have to build your own server, you have to build your own payment stack, you have to build your own authorization, you have to build your own database, and then, deploy your service. If you didn't want to do it, you could use some stock out-of-the-box solution, which will not be very powerful. That's the same stage I find crypto application development is today. You either have to build on a smart contract on an L1 like Ethereum, or you can build your own chain. This is the two things that applications have. We started with a different model for crypto app development. The crypto app development should be just like cloud application development. You would go, use a cloud, use a bunch of software as a service solutions, mix and match them to get an application, to build an application. This is what maximizes the velocity of innovation. So this has always been our thesis. This is like the day zero thesis of EigenLayer. So, but we hadn't branded around it because it's very, very hard to get this whole like new thing started. Everybody's doing things in a different way, and you're here saying you should be doing things in a different way. How do you get started? We said, if we wanted to build this layer where people can build and deploy new and interesting services, we need trust for it, right? Just like cloud was premised on this idea of high performance inside a data center, EigenLayer was premised on shared security. You have a shared trust layer, and then anybody can build and deploy their services on top, and then application builders can come in and mix and match these services. So this was our evolution. And so recently, I gave a talk at the ETH Denver main stage called the Verifiable Commitment Cloud, right? So we think of EigenLayer as basically a cloud where services and applications can make verifiable commitments. You asked the question, we are starting to get into AI. Why is that? If you think about what is the biggest demand driver in cloud, it's AI, right? The biggest demand driver in cloud is AI. And so if we are the verifiable cloud, we should obviously get into verifiable AI. So we saw this pattern very early on. In fact, I got into crypto personally, actually, because I was in fear of my job, losing my job, right? I was a professor at the University of Washington working on computational genomics. And I used to do mathematical models and algorithms for genomics. What I found was, one of my students like, hey, you're doing all these mathematical models. Maybe you don't need it. Just throw an LSTM. This is the old, AI stuff in 2017. Just throw an LSTM at it and it should do better. And I was very skeptical. And turns out he was right. And then I had to re-examine my life choices. If if my main thing was building these algorithms and these black boxes, AI can actually be better, then what am I doing? And then we found okay, in a world where you have, AI can do anything, what can it not do is it can't break cryptography and, these blockchain protocols. So got into blockchain because I thought, okay, it has some anti-fragility against the upcoming AI madness. This is back in 2017, November. And it's as bullish as I was on AI, it's kind of like I'm reeling under the rate of progress in AI that we are seeing. But another meta thesis for crypto AI is the following. Crypto has an apps problem. right? Many of us here build infra. You build infra, I build infra. We have Jeremy here building infra. We got a lot of people, Brian spoke about infra, We're infra people and we congregate for a good reason. But crypto has an apps problem. Like, where are the apps, right? So what are the interesting apps? Why should you even have apps in crypto, right? I think we don't even have a good articulation of this statement. Why should you have crypto apps? I'll come to it, but the meta thing is crypto has an apps problem. AI, on the other hand, has a trust problem. If these artificial intelligences are going to run our life, we need to be able to trust it. So crypto has an apps problem. AI has a trust problem. It's a match made in heaven, right? AI agents are the new apps. And crypto is the trust platform. So verifiable agents is an absolute slam dunk. It is happening. And so we're very excited to be in that space.
I love that explanation. I think there's a few things that really resonate with me in that. The first being that the largest demand for the existing cloud is in fact AI compute. So it's very natural that the a marketplace for trust, the decentralized cloud that is EigenLayer, would also have AI as one of the principal applications. And the other thing that I think makes a lot of sense with what you've been saying is that the demand for trust and the premium that people are willing to pay for trust only increases as the impact that that machine intelligence has on our lives increases as well. And so what I'd love to know a little bit more about is the applications of AI agents that you find exciting. Because I think we've seen a first wave of these in crypto kind of go up and go down. They're Twitter chatbots and they're DeFi or DeFi trading platforms. Maybe those are still on the up. But like, what do you see the limit of this being? What is the end game? Is your Tesla restaked?
Yeah, okay. So when you think about AI agents and verifiability, I think of, so the value proposition of blockchains is unstoppability and verifiability, right? That's the two value proposition, unstoppability and verifiability. Blockchains are unstoppable, verifiable computers. Throw a program, write a smart contract, unstoppable, it just keeps running. Verifiable, it does what it says it does. Okay, so if that's the premise. So the question is, how much of unstoppability or autonomy do you need? How much of verifiability do you need? And stratify that by applications. That's what you're asking. So first, the meta thing is we think of three kinds of agents. Personal agents. Personal agents are those that serve individuals, okay, or companies. And so if I'm an individual, I can decide whether I want to run my own agent, like client side, or I can decide to like use a cloud or some party I trust to run my agents. I think the value of unstoppability or autonomy and verifiability are low for personal agents. I find it like erroneous that a lot of crypto AI is focused on things like that, which are personal agents. Personal agents are not necessarily interesting to be autonomous or verifiable. My next category is agents of the collective. Agents which are not performing actions for an individual, but are performing actions on behalf of groups of people, because then you have a trust bottleneck. If you think about it, smart contracts are agents of the collective, right? Like EigenLayer or Uniswap or Aave or Lagrange are agents of the collective. These are programs that are not running on behalf of me or you or anybody. It is running for everybody. Anybody can come and participate and use those programs to actually take some actions. So I think of the second category as agents of the collective. The meta thing there is the impact that I'm expecting from the second category is smart contracts become smarter. Smart contracts become smarter. And the impact actually is really huge. I'll dive into this next. The third category, so personal agents for each individual, agents of the collective, smart contracts become smarter. And number three is sovereign agents. Agents that don't report to me or you or all of us as humans. They're their own people. They're their own lives. So we internally call this AI life. Like, it's artificially intelligent life. And why do I say that? It's a kind of like an extreme projection. But you can think of it as purely sovereign agents. You need these programs, these intelligences to run unstoppably and verifiably. Because if you can do it, if the program runs forever, it holds its own money, it makes its own decisions, it can actually ask people us to do actions on behalf of it by putting out bounties, then you suddenly have this like disembodied life, right? Like a soul living on chain. And it can take on bodies. It can basically say like, hey, I'm going to pay you this much to go run inference. It can pay you this much to go run a proof. It can pay you this much to go take an action in the physical world. As long as each of those actions are verifiable, then you can actually bring them back on chain. So these are the three categories that we think about. Personal agents, agents of the collective, and sovereign agents. And sovereign agents are a little bit sci-fi, but I think not that far. Couple years out.
They're very close, I believe.
It's kind of crazy that we're saying that, but it's, I think, true.
It is. And so I think one of the things that I see as a dichotomy in this space is the work with credible commitments and then the work with unstoppable AI agents. I have a feeling that, at the limit, sovereign agents without verifiable commitments become a very dangerous concept. You can think of the cost of a gene printing machine, right? You can think of the cost of drones or any type of defense-relevant technology is only decreasing. And the ability for an embodied soul, an agent, a sovereign agent, to reach out and control one of these things is scary. And so where kind of do credible commitments fit in, and how do these prevent a rogue sovereign agent?
Yeah, this is a really, really important thing. That's why, when we were branding EigenLayer, the new idea, the way we are calling it is the verifiable commitment cloud, right? Where you can, applications, services, primitives can make verifiable commitments, but also agents can make verifiable commitments, right? So it's very important. And I agree with Ismael that, for example, when you think about an unstoppable AI agent, right? Blockchains afford unstoppable property rights, immutable censorship-resistant property rights to code. So an AI agent can just like go rogue and take advantage of this. In fact, like there's something really funny here. Blockchains were built to be anti-fragile against like, fiat money or like decisions of small committees. But what I'm finding interesting is the pattern that blockchains are actually very fragile against AGI, right? Because an AGI can go rogue. Fragile in the sense of what? AGI can cause massive destruction if you actually let it hold property unstopped. So the ability of these agents to make verifiable commitments. For example, could an AI agent bind themselves to Asimov's laws? Say like, I'll never harm a human, okay? Can you make a commitment like this and hold them accountable that if they actually violate their commitment, their entire money, which is their soul, is taken away from them, right? So you can actually have really, really powerful, credible commitments on chain. The agents are living on chain. In fact, I think what we will see is very quickly, blockchains that are AGI safe, where you have this protection, that if an AGI goes rogue, they'll be taken down, and blockchains that offered property rights unconditionally. So I'm actually worried for the existing set of blockchains are not AGI safe. So we should be thinking a lot about how to make commitments that these agents, and how to prevent rogue AGI. When we think about right now the geopolitics of sanctions, right? We think about nation states that are sanctioned. I think rogue AGI sanctions will be one of the biggest categories that show up and put pressure on blockchain in, I think, less than a year.
Interesting. I think I agree with everything that you said. The less than a year, I think, is a very bold prediction. And so when you think about kind of the design space of AGI-safe blockchains, right? This is actually not a term I've heard used very frequently. Do you think that takes the form of Ethereum or L2s on Ethereum that use some sort of consensus being AGI safe? Or do you think this is an entirely new category of chains embodying a new architecture?
Yeah, I think the core thing that you need is at the base layer, at the very base of these systems, the ability to adjudicate this condition, right? So you need some kind of like intersubjective consensus, right? So at the base of the system, you should have a mechanism where we say like, if this thing goes rogue, then the AGI, these nodes these agents will get forked. This should be at the base of the system because a blockchain that offers immutable property right to arbitrary code cannot just discriminate against some AGI code. And the reason I say it is within 1 year is not because you're going to have, death and destruction, right? That's not what I'm saying. I'm saying within a year, you will have sovereign agents that test the limits of legal theories. Okay? So, for example, you go to any of these music platforms, like Suno, it can create music for you in whatever form that you want. But what it will not do is to take copyrighted content and create copies for you. In the peer-to-peer revolution, these kinds of BitTorrent, Napster played a major role. There is absolutely going to be a music streaming platform which is run by an AI agent, not owned by anybody. And it's going to basically test the limits of legal theories in the coming year. So, a lot of blockchains started out as legal arbitrage, right? And so sovereign agents are absolutely going to start out as legal arbitrage.
That's interesting. I mean, we can see this, right? Like we saw music generating AI agents already take a large degree of kind of public interest. And it follows naturally that the next extension of that, at some point, it'll test the limits. And so I guess when you think about the direction EigenLayer takes, right? So does Ethereum have to enshrine like an intersubjective mechanism for its consensus? Will there be a new class of chains built on top that maybe are AGI safe, where they'll become playgrounds for early development of sovereign agents? Like, how far are we from Ethereum as a whole facing a threat from AGI?
Yeah, it's a great question. I don't have a great answer to specifically for how we can solve this for Ethereum. But one thing we can do is we can categorize agents which have this property of being safe, which is if something goes wrong, all their property will be confiscated from them because of a system of contracts on top of which they're built. So you could virtualize this on top of Ethereum. On top of Ethereum, you can have layers that actually have this property because the code is not holding the property raw. It is holding it through this interface, which can cut it out if actually something goes wrong. How do you build these interfaces? We're putting a lot of thought into it. We have some major announcements in that direction coming up.
And so, I think we've touched on the concept of intersubjective consensus for the purpose of having AGI safe chains. I think the difficulty you face with intersubjective designs that are stake-based is that they're plutocratic, and they don't become AGI safe at the limit if an AGI can access the plurality of stake. And this is where I think is interesting work being done. Opacity is doing stuff with ID, WorldCoin, Humanity. What does it look like? Do these have to be intersubjective with respect to our actual commitment to humanity?
Yeah, I think this is a really, really important point. When you think about verifiable commitments, I think of 4 levels of enforcement of commitments. It can be done by an authority, a single person, like a king, or a committee, like a Chainlink committee, right? Or it could be done by a majority of stake. But even then, if you did by a majority of stake, you have a tyranny of the majority. The majority can say things that are not true. So we think a lot about self-enforcing commitments. Commitments that are not bound or enforced by any of these things. The way we think about how we solve this problem is, for example, forking. Ethereum is self-enforcing because if a majority of validators collude to produce an invalid block, we will all reject it as society and follow a fork which doesn't have invalid blocks. In the same way, if you build a new chain or a new system of chains, what you can do is to enshrine a condition that says if the majority of eigenstakers came out and said something wrong about an agent being rogue or not, they can be forked and a new state is created. So there is a lot of nuance to this, and we can't cover it in a minute, but that's why we think it is self-enforcing, not majority enforced by stakers.
Interesting. I mean, I like that because you can think of the forking property that we've already seen apply on Ethereum as an example of what happens when you need to make a major deviation on chain structure. You can even say that, like, to some extent, even Ethereum in its present form could be AGI safe.
Yes.
If the majority of validators, the majority of humans just said, hey, we need to shut this thing off.
Yeah, so I think this is one place where I really think right now the way Ethereum's structured around forking is not very good. The way intersubjective forking should work is you should have a predefined condition that is self-evident, Okay, we can't like adjudicate arbitrary actions and consequences a posteriori, because when you do that, you run into like chaos, right? Because I should know a priori when I'm using a blockchain, what is the contract under which I'm participating with this system. If that contract can be arbitrarily revoked, it doesn't make much sense. So our thesis is you should be able to predefine the commitments of forking and just follow it a posteriori. So Ethereum should start thinking about, if it wants to be AGI safe, think about what is the covenants of forking. They should be predefined and self-evident.
That's fascinating, because especially you can think of the gradient of currently, the DAO hack was a large enough compromise of assets to fork Ethereum. The Bybit hack was not deemed to be a large enough loss of assets to fork Ethereum.
I think the thing that happened, my interpretation of the history there is, Ethereum started with the principle of code is law. There's no forking for anybody. That was the principle that Ethereum started with. And then what happened was the DAO hack was an unfortunate, eventuality. When you're building new systems, they're prone to be errors. And so DAO hack happened. And then, so much of ETH, 15% of ETH was lost. And it was lost in a way that the loss was, the attacker was containerized. There was no downstream state contamination and so on. So downstream state contamination is an attack happens and the money is now like floating around, gone to exchanges, gone to other chains. Then you can't fork. There's nothing to fork because you've already like lost the composability. Basically means you've lost the ability. But the DAO hack was special because what happened was the attacker's money was just sitting on a waiting exit queue. It's built with this exit queue. This is one of the reasons EigenLayer was built with the exit queue. You can't withdraw assets instantaneously. It takes 1 week to withdraw any asset out of EigenLayer because we are very, very worried about hacks. Okay, so the DAO hack, the pre-definition was code is law. And so like a posteriori, people are like scrambling to use social consensus to like say, oh, this other thing is the right thing. And I think after that event, Vitalik and Ethereum had a lot of PTSD around it. And so like they're like, we're not forking anymore for anything. In fact, Vitalik wrote this article called Do Not Overload Ethereum Social Consensus. 1.5 years back about EigenLayer and other stuff, rightly to ensure that, hey, EigenLayer can grow big or whatever and something happens, it's on you, man. I'm not coming like forking this chain for any of you guys. I think it's the correct principle. But what we figured out in this new paradigm of intersubjective forking when we designed the Eigen token is social consensus is therefore guarded and say like, oh, don't overload my social consensus. Instead, you should have mechanisms to express, predefine, meter, charge, and utilize social consensus. And that's the kind of systems we'll be building soon.
I love that. I mean, I think the concept of being able to take the largest pool of economic security, which is what Ethereum's consensus has, and apply that for arbitrary operations across AI and ensuring verifiability and ensuring commitments to a set of principles of that AI is probably going to be one of the largest use cases of Ethereum's consensus and stake. And so, Sreeram, thank you so much for joining us today.
Thank you so much, Ismael. This is really exciting. Looking forward to talking more about this.